Today's video will cover solving systems of equations using substitution. By the end of today's lesson, you will be able to identify when to use substitution to solve a system of equations, and be able to use substitution to solve a system of equations for both variables. Let's start by looking at when do we use substitution. You use substitution when one of the two equations is in y equals or x equals form. So in other words, one of the two variables is by itself. So for example, if our two equations are y equals 5 and 3x plus 2y equals 22, we should be able to solve to see what x is equal to. We already know y is equal to 5. So using our equation, 3x plus 2y equals 22, take the y value of 5 and we're going to plug it in, or substitute it in for y. So we get 3x plus 2 times 5 equals 22. We now have an equation with a single variable x that we can solve. So we get 3x plus 10 equals 22. We're going to subtract 10 on both sides, giving us 3x equals to 12. Divide by 3, and you get x is equal to 4. So this is a very basic example using substitution. The key you want to take away from this example is that we're using substitution because we have a variable that's already by itself. Try that again. Better picture. There we go. So because y is by itself, we know what y is equal to. We can substitute it into our equation, again, giving us an equation that just has a variable x. Now, most of the time, you're going to see examples like this, where we have y equals, but what y is equal to is actually an expression. So in this case, y is equal to 4x minus 6. What we want to do is go to this second equation, take 4x minus 6, and substitute it in for y. So I'm going to rewrite my second equation as 5x plus 3, and then instead of y, I'm going to write what y is equal to. In this case, y is equal to 4x minus 6. So what I now have is an equation with one variable that I can now solve. We're going to distribute. The 5x didn't change, so we're going to rewrite that. 3 times 4x gives us 12x. 3 times negative 6 gives us negative 18. And we're going to keep following the same steps that we use for solving multi-step equations. So I'm going to combine my like terms, giving me 17x. Bring down the negative 18. I'm going to add 18 to both sides, giving me 17x equals to 17. And then divide both sides by 17 to get x equals to 1. So that's the first part to this process. We've solved for x. We solved for x by substituting in our expression for y. So we took y, replaced it with 4x minus 6. It gave us a multi-step equation with a single variable x. We solved for x and found x is equal to 1. Now, unlike the original example, y is not, we don't know what y is equal to. So what we want to do is take that value of x. We know x is equal to 1, and we're going to plug that in. So we're taking our answer that we got from step 1 and substituting it in. And so simplifying this gives us y equals 4 minus 6, or y equals negative 2. You want to make sure when you're doing these problems that you do not stop when you find the first answer. All of these questions, unless it's a no answer, or no solution, or an infinitely many solutions type question, you should get a value for both variables. So make sure you go on and do that second step. It's a quick step, but it can be easily forgotten. One final example. Here we have one equation that's 2x minus y equals to 8. Our other is y equals 2x minus 3. So here's our equation where the variable is by itself. And we know y is equal, in this case, to 2x minus 3. So let's take our first equation. We have 2x minus y equals 8. And we're going to take out y, and we're going to plug in 2x minus 3. So there's our substitution step. Now here we have to be careful. We've got this negative. We've got to distribute that negative to both of the terms. So we get 2x minus 2x plus 3 equals to 8. In this case, when we combine our like terms, we get 0x. They both cancel out. They're opposites. They create 0 pairs. They cancel each other out. All we're left with is 3 equals to 8. If you think back to what we did with multi-step equations, when all the variables dropped out and we were left with an equation that didn't make sense, we have no solution. So in this case, the same thing happens. The variables drop out. We're left with 3 equals 8. 3 doesn't ever equal 8. So therefore, this problem has no solution. When you get a no solution problem, there's no second step. You don't need to go back in and try to solve for y. If there's no solution, it means that there's no solution for x or for y. Okay, we've done 3 examples together. It's now your turn. Use the first example and the second example, the second example and the third example as a guide for how to set this up. You're going to go ahead and substitute your expression for y in. It'll give you an equation just in terms of x. Solve for x and make sure you go back and solve for y. Once you've completed, press play again, and the answer will be on the screen. Here's what your solution should look like. In your first step, you should get x is equal to 4. Make sure you plugged in the correct expression for y. Make sure you then distributed the 5 correctly, so you should have 15x minus 65. Make sure you combined your like terms, and then solve the 2-step equation correctly to get x equals 4. Hopefully we didn't stop there. Hopefully we continued on. Use our original expression, our original equation for y, plugged 4 back in for x, and we got y is equal to -1. As always, if you have any questions or concerns, please make a note of them now so you can get your questions answered in class. You can also go back and rewatch examples if necessary.